Okay, factoring trinomials. Let's get into this. The only thing I want to clarify before we get started is that we're going to be factoring trinomials where that's the eraser. Where a or the coefficient at the beginning of the trinomial is equal to 1. So we're only going to be factoring trinomials like, let's say, this is an example problem. This is not, but I'm just using it to explain. This is a right here. Right now there's a 1, invisible 1. So I'm only factoring trinomials where that a is equal to 1. If you're looking to factor trinomials where it's not equal to 1, I should be making another video on that pretty soon. So now let's get into the video. Let's say we had a problem like x squared minus 10x minus 24. Now, we know that the factored form is going to be in this format. It's going to be in 2 parentheses. And I'm just going to say there's 4 different components. This, and this. And in each parentheses, the 2 components are going to be adding or subtracting from each other. And then when you multiply them together, you will get to this trinomial. Okay, so that's what we're looking for. We're trying to fill in these parentheses through factoring. Okay, the first thing we're going to look at is these first 2 components of the parentheses. What's going to be right here and what's going to be right here. Okay, and then we're going to either add or subtract them from the second component, which is there and there. But right now, we're just focusing on what's going right here and what's going right here. Now, since we're factoring trinomials where the a value, or this invisible number right here, which is 1 in this case, is 1, this is actually really easy. This first component is always going to be x, because I want you to understand that the first component of each parentheses, they're always going to multiply together to get this first value in the trinomial. So in this case, we have x times x. They are multiplying together to get this x squared right here. Okay, let's say we had a negative x squared right here, right? These 2, they should multiply together to get a negative x squared. So positive times a negative is going to get you a negative x squared. So we can add a negative right here. So x times negative x is going to be that negative x squared. So that's how you find the first component. They're both x. They're always going to be x if the a value is equal to 1. Okay, so that's really easy. As soon as you're given a trinomial problem like this, right away, you're just going to want to put the x there. The only thing you have to pay attention is whether you're going to add a negative x, if this is negative, or just keep it positive. Okay? So we have that done already. Okay? The first component is done. As of right now, let's ignore whether there's going to be a plus or minus in each of these categories. Let's just focus on our second component, or the second value in the parentheses, which is going to be right there and right there. Okay, how are we going to find those? Well, let me just give these components variables. So I already have our x. Let's say that I call this right here a. Actually, no, let's not call it a, because I don't want you to confuse it from this a right here. Let's call it, I don't know, h, and let's call this I. Okay, so you're looking for h here and you're looking for I here. What's important to know is that h times I is always going to multiply together to equal this value right here. So this is the c value, it's negative 24. H times I must equal negative 24, okay? That is something that you need to know when figuring out your h and I in this case, or your second component. The second thing you need to know is that h plus I must add together to equal this number right here. Okay, so if you're taking notes, write that down. If not, remember it. Okay, h plus I must add together to equal this. So they need to add together to equal that negative 10. Okay, so now we know what rules our h and I, or our second component, must follow. We already have the first component, which is x. So now we must look for what values fit h and I, where h times I is negative 24 and h plus I is negative 10. So first let's think about negative 4. What multiply together to equal negative 4? 8 times negative 3. That's 1. What's another one? 12 times negative 2. So automatically we see for the values right here that 12 times negative 2 is going to add together to equal the negative 10 value. So that fits our second rule. So what you basically have to do is look at your number right here, negative 24. Look for h and I values and multiply together to get your negative 24. And look for values that add together to get your negative 10. So you're looking for h and I values that satisfy both of these rules. And as soon as I saw that 12 times negative 2 is equal to negative 24, I know that this satisfies both of them, because 12 plus negative 2 is equal to negative 10. So I know that my h and I values can equal 12 and negative 2. Right? They can equal h and I can equal 12 and negative 2. Now they're interchangeable. 12 can be h and negative 2 can be I, or vice versa. It doesn't matter. Okay, and just to clarify once more, I know that these can equal h and I because 12 times negative 2 is equal to negative 24, and h plus I is equal to negative 10. So we just keep multiplying to find things that equal negative 24, and once we saw two things that multiplied to get negative 24 that added to get negative 10, then we had our h and I values. And remember, these aren't called h and I values. I just decided to give them those variable names. Okay. So now that we have our h and I, I'm just going to assign h as 12 and I as negative 2. Again, it doesn't matter which is which. We can plug them in. Okay, so we know that this is a plus 12. It's positive, so there's an invisible plus inside of it. So we're just going to add that. Plus 12. We're adding that right here. This is a plus 12.